Okay, so let's continue with this 1-5, and let's see how far we get. So last thing we did was that congruence thing. It's a word that we've seen before. You haven't, I don't know, you probably haven't discussed this in math before. But it's a very common word, nothing fancy about this word. But when we talk about points on a line, or in this case a line segment, we need to kind of have a definition for that. And the word is between. You're like, okay, I know what that means. Okay, we're between something. So for instance, if I took point B right there, and we're using this word between, tell me something about point B. Where is it located? Point B is located, what? Between what and what? Yeah, point A and point C. Pretty easy, right? Could I say that point C is located between A and B? No, I can't, because it's not between. Like point B is not over here on this side. You got to have the point on one side, the point on the other side. Everybody got it? Yeah. All right, so really that's the only, let's get rid of that circle right there. Okay, that's the only thing right there. Let's do this though. What if I said AB? This is something I think we talked about on Friday. Might be in your notes. What if I just had AB and no line over top of it or anything like that? What does that mean? Somebody tell me what that means. No? Just AB. No, it means something really specific. Look in your notes. Gianna? Say it again. The length of. Very good. The length of line segment AB. It means the length of. Now, we don't know the length of this, do we? We haven't measured it. Nobody put a number there. We don't really know. But when we talk about the word between, we're going to talk about the lengths of line segments. So if I took line segment AB and I added, I should say the length of AB. If I take the length of AB and I add it to the length of BC, what do you think that's going to equal to in terms of A, B, and C? Okay, no numbers because you don't know what any of the numbers are. But if I took this segment right here, the length of it, the length of AB, and then I found the length of BC, and I added them up, what am I going to get?
AC squared.
Squared? Nothing squared. We're not multiplying anything. We're just adding. We're just adding. Say it again. It's not ABC because we don't name a line segment with 3 letters. AC, exactly right. You got it. Okay, now let's take a look at it. Let's see if that makes sense. The length of AB. So let's make up a length. I don't know, 7. All right. If that's 7, what do you think BC is? 3. All right, that's good. All right, so if you put numbers in here, it's pretty easy to figure out, isn't it? So look, the length of AB in this case is what? 7. Plus the length of BC. What's the length of BC? It's 3. And so what is the length of AC then? From A all the way to C? It's going to be 10. Does it make sense?
Yeah.
All right. That means between. Do you see how the B is right here and the B is right there? That means B is between A and C if you write it like this. Everybody with me on that? All right. So what does the 7 mean? It means the length of AB. All right. So I just put a 7 in for AB. And what does the 3 mean? It means the length of BC. Okay, if I add up this line segment, the length of this line segment, plus the length of this little line segment, if I add them up, I'll get the whole big line segment, which is line segment AC. We're going to be doing a lot of that, not just with line segments, but we do with angles and other things like that, okay? Everybody good with that? All right. Now, we're going to get a little bit more difficult. What, that? Okay, I'll keep that right there. All right, let's do this. It's going to kind of look the same. Actually, it doesn't have to be a line. It doesn't really matter, to tell you the truth. But I'm going to put a point here, and I'm going to put a point right there. Just make it a little smaller. So that's B, that's A, that's C. So still ABC. But now, what I'm going to do is I'm going to put a value for AB, but it's not just going to be just a plain old number like this. So watch really, really careful. You ever wonder in algebra why in the world you needed it? Okay, this is one example of where algebra really comes in handy. This is still a geometry problem, but we're going to use geometry to set up an algebra problem. All right, so I'll show you what I'm talking about. So let's put this 6. Now, if I just put 6x minus 1 right there, what does that mean to you? That means that, well, it doesn't mean 5x. It's not 5x. What does that mean to you as far as this picture is concerned? What AB? Tell me something about AB and the 6x minus 1. Say, Amy. Amy. Yeah, that's what that means, but in relationship to the A and B. Like right here. AB, what is the 7 to the AB? It's what?
The length.
It's the length. It's the length of that line segment. So right here, what's the length of line segment AB?
6x minus 1.
But the problem is I don't know what x is, right? But we're going to be able to figure out what x is with the information that they give us, okay? This is where your algebra comes into play here, and it really is beneficial. All right, so it's 6 times some number minus 1. That's the length of this right here. And then they tell you that this is 5x plus 10. You understand if I just stick it right there, that automatically means it's between A and B, right? The 6x minus 1. Is, and then the 5x plus 10, if I just stick it right there, that means it's the length of BC.
Yeah.
All right, it's very important that you understand what that means. Now, they tell you, here's the problem. It says, find AB and BC if AC is equal, what is it, 75. Here's the problem. This is a problem that, it's a style problem that you will see. Whoops. Didn't include the top of that 5, did I? All right. So this is a problem that you're going to see on a homework, on a quiz, on a test. And this is the first time that you've seen this kind of problem, but it's not the last. You're going to see this kind of problem over and over and over again, all through the whole entire rest of the year. What I mean by that is this. They give you a picture. They give you some information about the picture, and what you have to do is you have to look at it and say, what can I do with that picture to solve for x? And I'm not just solving for x. What am I really trying to find? I'm trying to find A, B, and B, C. All right? But I got to know what x is first. If I know what x is, I can find AB. Agreed? If I know what x is, I can find BC. All right? And then that's what you're looking for. This is what they want you to find. So just because I solve for x doesn't mean I'm done. I got to take that x, put it back in, and figure out what this AB is equal to. So what do you think we're going to do? No? Put them together? Okay, we are going to, but what equations? What am I going to do, Tim? Okay, well, what am I going to do before I start actually doing the arithmetic? How do I want to set it up? Remember what we did earlier? The AB, what's true about the AB and the BC? They add together, right, to be what? 75. They add together to be AC, which is 75. So AC is correct, but I was looking for numbers, okay? So AB plus BC equals AC. So what is the AB? This time it's not 2 or 7 or whatever number I made it before. What is it? 6x minus 1. And what am I going to do to that 6x minus 1 in this 5x plus 10? Just tell me. I'm going to add them together, right? So I'm going to add it together. Now, if I add them together, what's it going to equal? What is it?
11x.
Nah, not yet, not yet, not yet. If I add this together, if I add this segment and this segment together, it's going to equal, say it, 75. All right, because of this, because they told you that AC was 75. Everybody with me?
Yeah.
So that whole thing is 75. 75 whatever. Inches, centimeters, millimeters, miles, feet. Doesn't matter. Okay, it's 75. But I don't know the exact value of this. I don't know the exact value of this. But I do know it's 6x minus 1 and it's 5x plus 10. So now we're finished our geometry. Our geometry is basically done. So what was our geometry? Our geometry was just to take this, and the 75 and do something to them, right? You add them up, set them equal to 75. That was our geometry. We had to understand that those two segments added together equals the whole big segment. That was our geometry. Now it's just work. I told my other class, it's just work, it's just algebra, it's not really a lot of thinking. Algebra is not really a whole lot of thinking, to tell you the truth. It's just following a set of steps and just boom, 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 right? Geometry, though, it takes a little bit of thought. You got to look at it. You got to sit back and like, okay, what do I do with that 6x minus 1? What do I do with that 5x plus 10? And what's up with that 75? Where does that come into play? All that stuff you're asking yourself, okay? And then you look at it and like, oh, yeah, those two segments add up to be the whole thing. So there's one segment, there's another segment, there's the whole thing. Does this make sense?
Yeah.
All right, let me know if you're lost. All right, now we can do the work. All right, so now, Caleb, you're going to do this, right? What's our work? Let's do some algebra here. What do we do on this side? Add like terms. So what am I going to add? Right, well, 6x. 6x plus 5x, which is 11x. I don't know if you do this, but sometimes one that's this short, I don't normally do this, but if I had one that's really long, you ever do that?
Yeah.
Okay, I like to like mark them out so I know I'm done with it. And then what else can we add up over here on the left-hand side? Negative 1 plus 10, which is
9.
positive 9, so we put a plus 9. And that will equal what? 75. Okay?
Subtract 9 from 35.
We will in the next step. Okay? So that's our first step, adding like terms. Now the next step, I always tell my students, if I was teaching Algebra 1, I tell them always add or subtract. Okay? Always add or get rid of, I should say it this way. I want to get rid of what's being added or subtracted. So what's being added or subtracted over here? The 9. So I get rid of that. How do I get rid of a plus 9?
Minus 9 minus
Subtract a 9. Do it from both sides. Is it coming back to you now?
9. Yeah.
Aren't you glad you paid attention in Algebra 1?
No, I did.
Well, apparently
Okay,
you did a little bit because you knew to subtract 9 from both sides. All right, let's so I like to mark them out. That adds up to 0. So what do I bring down? The 11x. Bring down the equal sign. 75 minus 9, 66. Yep. So 6 and 9 is 15. One more step, and we're almost done. We're not quite done.
Divide 11.
Divide both sides by 11. So what's x equal to?
6.
Is that my answer? Do I circle it? Do I go on to the next problem?
So if you go and do the
Do I?
you circle it.
Do I?
No,
Is that what they
finish it
asked?
out.
Is that what they asked for?
No, you finish it out.
What do you mean finish it out?
We go
What's my problem? What are they asking me to find?
find A, B, and B, C.
Right, they're asking me to find A, B, and B, C, aren't they?
Oh, and then you go
Okay.
back and put
So I got to take AB. What was AB?
6x.
6x minus 1. So I'm going to put 6 times what?
6.
6 minus 1. And what's that? This is AB.
35.
36 minus 1 is
35.
35. Okay? And then what about BC? What about BC?
40. Oh, yeah.
So I could do it two ways. What's probably the easiest way? Once I get AB, what's the easiest way to find BC?
5 times 6.
You could do it that way. I don't think it's the easiest way. What do you think the easiest way is? Yeah. That's what I would do. Okay, I think the easy. Remember, the whole thing is 75, isn't it? Right? So from here all the way to here is 75. This little bit right here, what did we say this was? That was 35. So what would I do? 75 minus 35. And what is that?
4.
It's 40. Okay? Or Tristan, I could do it the way that you said, and that's perfectly fine. There's nothing wrong with either one of them. Okay? I just think this might be a little bit easier, but it's perfectly fine either way. So let's find what BC is. So what do? 5 times, which is 6, right? And then plus 10, right? 5 times 6 is, plus 10 is, so either way, you get the same answer, don't you? But this is what they're looking for right there. So don't just circle x equals 6 and go on. Back in algebra, that's almost what you did almost the whole year, wasn't it? You just solve for x, circled it, boom, you move on to the next one. But on this one, you have to understand that you got to plug it back in, right? Plug it back in for what they're asking for. It says to find A, B, and B, C. Plug them back in, and then you got your answer. That's a very, very common problem. It's a common type of problem that you're going to be doing in geometry, okay? If you look at this, you're like, I think I can do this. I think this is not so bad. Then you'll probably be fine with geometry. This really is a struggle. Let's figure out how to do it now because you're going to see it a whole lot later on, okay? All right, everybody good with this? Questions on any of this stuff that I just did? Now it's time to ask. All right, let's do one more thing, and then we'll stop. When's this over? Quarter of
15.
or 50? Is it? It's not 15. Nobody knows.
I think it's 50.
I got a thing right in front of you. It is 50. Yep, 50. Okay. So we'll finish a little early. I'm sure you won't mind that. Let's do one more word. Everybody look up here. You should be writing this down. We'll call this line segment XY. All right, there we go. I'm going to do one more thing. This is the last thing we talked about on Friday. I'm going to put a little tick mark here and here. What does that mean?
That they're the same length.
What's the same length?
The two lines.
Give me a number. Give me letters. Give me
XM
XM and
and
MY. Right. Means that they're equal to each other. Everybody see that? So if I put a little mark here and here, that means that XM, that length right there, is equal to MY. Or we can say those two segments are congruent to each other. So what does that say about point M then? M's where? Where is it located? Yeah, it's right in the middle. Remember we said before, I think we said it in here. This is the third time I've taught this today, so I can't remember who I said this with. Remember I said this, did I say this? Did I say that B is in the middle? Did I? I never said that. No, B is not in the middle. It's between, but being between doesn't mean it's in the middle. In the middle means dead center. There's just as much on the left. Shh, listen. There's just as much on the left as there is on the right. Okay, let's go back to this. Now, M is definitely between X and Y, but is M in the middle now? Yes, it absolutely is. Why do we know that? Because there's just as much over here on this side as there is over here on this side. Okay? They're the same length, so it's got to be dead center, dead in the middle. Well, we don't call it the middle, but we do give it a name, and we call it the midpoint. It's one word. And that's something that we're going to be discussing quite a bit. It's called the midpoint. So if M is the midpoint, then I know that the length of XM is equal to the length of what? MY. Okay? Or I could also say this. Remember, there's a subtle difference between the length of, or I could say this. I could say that line segment XM, not talking about the length, I'm just talking about the segment itself. Line segment XM is what to line segment MY? It's not just equal, but it's right. It's congruent. So when we put line segment over top of it, they're always going to put congruent. If they don't put the line segment over top of it, that means the distance or the length of that line segment. All right? Again, it's a subtle difference. Most students don't really care. And to tell you the truth, I don't really care all that much, to tell you the truth. But if you see in the book, you'll notice that sometimes they'll write congruent, sometimes they'll write equal. Well, this means, it means the length of it are equal to each other. This means the line segments themselves, I could take one, pick it up, put it right on top of the other one, and they're exactly the same. They'll be in the same starting point, same ending point. They would be equal. All right? All right, I think that's it. I think we'll stop right there. Is that all right? So no homework tonight. If you want to start on the homework, you can look on your lesson plan thing,
I didn't know
and you can start on it.
no school. Do you have no school Monday?